In this presentation, we're going to look at waves found on the electromagnetic spectrum. So, what is a wave? Well, a wave is a disturbance in something which is associated with the transfer of energy. As the picture shows, if you drop something into water, you disturb the water itself and you introduce some energy. Let's say you've dropped a rock in the water. What will happen is that rock has energy which transfers to the water, and that energy then is transferred out from where you dropped the rock in terms of a wave. So that's how you get those ripples in a pond. There's two types of waves. The first one is longitudinal. These are waves of a special type, and they're basically sound waves. If you have a look at the animation here, you can see that the red line is going back and forward, and effectively what it's doing is it's compressing air, which is what your vocal cords do. The exact opposite to this happens in your ear, where the compressed air hits your eardrum, and those compression waves are then turned into sound by your brain. So the longitudinal wave, the actual direction of the wave is exactly the same as where it's moving, and that's why it's called longitudinal. Transverse, however, is more like the wave that you'll get if you start flicking a slinky spring or a piece of rope or something like that up and down. You'll see those waves where you get hills and troughs moving along the spring or the hose, and that's called a transverse wave, and the motion is at right angles to the direction of the wave. Both of them transport energy, but the substance that the wave is in doesn't actually move anywhere. It might move up and down, but it doesn't move along. And a transverse wave, a good example of that is light, and an example of a longitudinal wave, as we talked about before, is sound. Some properties of waves. Each wave has a frequency, and this is the number of waves produced each second. It's measured in hertz, so 2 hertz are 2 waves per second. You'll find that the frequency of waves varies as we go through the electromagnetic spectrum, and we'll talk about that a little bit. The wavelength is the sort of inverse of frequency. It is the distance between 2 successive waves. Now this is measured in meters, and some waves in the electromagnetic spectrum are very long, maybe kilometers, and some of them are extremely short and can be measured in thousandths and so on of a millimeter. So we have a real, I guess, variety of different waves in the electromagnetic spectrum. The amplitude is a measure of the intensity of the wave, and that's the maximum distance it extends beyond the middle position. This might be a little bit hard to understand, but if you can think of it, a bit like listening to a radio or a recording or your phone, and you've got a sound, but if you turn the volume up, the intensity of that increases, and so does as the volume does. If you turn it down, the intensity decreases. You can think of volume as a little bit like the changing of waves, where the intensity of the wave increases and decreases, just like the volume does when you're listening to some music or whatever through some sort of device. Okay, so let's look at the electromagnetic spectrum. Now, when electric charge moves, it creates this field of energy around it in the form of waves. These electromagnetic waves occur naturally in space, and often synthetically created to help us live here on Earth. And you'll say, well, I haven't seen any synthetically created electromagnetic spectra, but when you turn on the light in your room, you are actually generating some of those electromagnetic waves. And by having the light on, you've synthetically created the light so you can see. And that's just one example of how we use these waves to help us live. You might be able to think of some others. This look probably is a little bit confusing, but you can see that these are transverse waves because the actual wave motion is 90 degrees to where it is traveling. Okay, so let's have a look at the spectrum. We have really long waves, radio waves, which are in the kilometers of length, right up to gamma rays, which is 10 to the minus 12, which is point with 11 zeros and 1 of a meter, which is pretty small. Not something you could measure or even see with the naked eye if we could see waves, because they're so small. Alright, so let's have a look at some of these waves and what's important about them. Okay, radio waves. They measure from 1 meter to 100 kilometers or 100,000 meters in the range. So they're big waves, long waves. These have a frequency of what's called 3 by 10 to the 4 hertz, or 3 that it would be 30,000 to a rather large number per second. Small number rather. The uses of these are obviously for telecommunications, TV, radio. So the signals you receive for your television or your radio fall in the radio wave bandwidth. No dangers of radio waves that anyone knows of, and they've been around for years and years and years and don't seem to have affected anyone. Microwaves. Now, the obvious one that you'll come up with is, yes, we reheat our food in the microwaves, but these waves are used for other things than just reheating food. They are 0.001 meter, which is 1 millimeter to a meter long, so they can be relatively big waves, and there's the frequency. And their uses are telecommunications, radar, and cooking. Cooking's the obvious one. Radar, you can think of either using in an airport or on ships or something like that. Your mobile phone uses microwaves. Your Wi-Fi uses microwaves. So they're very, very useful waves in this bandwidth, and we use a lot of them all around us. Dangers, we know that if you stick your hand in the microwave and cook it, it will cause burns. It can also affect your eyes, and the studies are going on, but no one has really indicated that they cause cancer. And there are some people saying that use of mobile phones cause cancer, but there's no real study to show that as of yet. Infrared. These are not seen. They are smaller, obviously, than microwaves, and their uses are heating, because they, as they say, infrared, they're hot or heat, waves of heat. Your TV remote uses infrared waves. Some cooking uses infrared, and you might have seen night vision on TV or in a show talking about military. This uses infrared waves, and we can see infrared signatures from either people or machines that have heat that show up as bright colours in an infrared camera. The dangers is that because they're related to heat, they can burn the skin. Visible light. Okay, again, much smaller wavelengths, and these vary in colour from violet to red. The uses, well, we couldn't see without visible light, so it's pretty important for us. And if we had, because of that range of light, we can see then different colours around us. The dangers, really, the real damage is eye damage from bright light. So if you look at the sun, you'll find, and keep looking at it, you'll find that you will damage your eyes. If you are a welder and don't use eye protection, then that bright light that is generated by the welding electrode and the metal can affect your eyes. So visible light is the best one to get through our atmosphere. As you can see from that graph, the green stuff is getting through our atmosphere, and that's good because we need it to see. Ultraviolet. The wavelength, again, much smaller again, so it's getting, the wavelengths are getting smaller and smaller. That means the frequencies are getting bigger, because if it's a very small wave, then lots and lots of them can be generated in 1 second. The uses, well, discos, counterfeit defections, pollination. Bees use ultraviolet light to find where honey or nectar is, but also pollen. Counterfeit detections can be used, as the picture shows at the top with the American $20 note, can pick up if the note may be a counterfeit. Dangers, the skin cancer. Now, down the bottom there you'll see a tanning booth with a big cross on it, because these are really discouraged, as it's been proven that ultraviolet light, and certainly too much of it, without good skin protection can cause skin cancer. And there's a range of skin cancers. There's a couple of ones that aren't so aggressive, things like basal skin cancer or squamous cell cancer that people can get on their skin, and these can be taken out. They're actually cut out by a doctor or a surgeon and made sure that it doesn't move around the body. The ones that are the more aggressive are the melanoma, and these can be much more aggressive and can cause people a great deal of problems with cancer. So take care with ultraviolet light and make sure you slip, slop, slap and protect your skin. And as we said, bees use C and UV and help them find the pollen. X-rays. Now these are shorter again in wavelength, so they're a higher frequency. These are used in obviously medical imagery. So if you've had they think you've broken a bone or you have some other health issue, they may do an X-ray to see what's going on inside you. Or at the airport, they use X-ray on your luggage to see if you're carrying something that you should or maybe not. And you can see these X-rays actually color code different items in someone's suitcase, so it makes it easy to pick up if you are carrying something that you shouldn't. Now, X-rays can cause cancer, particularly with excess radiation. I don't know how many of you might have had an X-ray, but if you have, you'll notice that the person who is doing the X-ray usually either hides behind some sort of partition, or they may wear a special vest that is actually filled with lead. And this stops continual radiation from getting to their skin tissue, and too much radiation can affect the skin and cause cancer. So a doctor will not give you too many X-rays. One X-ray now and then, or a few now and then, aren't going to be a problem for you. Gamma rays. These are probably the most energetic, if you like, the shortest wavelength and the highest frequency. They're used in cancer treatment, and they're also used in observing the universe. Just like X-rays, they can cause cancer or even radiation sickness, which is pretty awful. So the dangers of the electromagnetic spectrum, well, as the wavelength of the electromagnetic spectrum changes, the way that the different wavelengths interact with matter also change. And we can call this an ionizing radiation. So if they have long wavelength or short frequencies or low frequency wavelength waves rather, then they're non-ionizing. And these are radio waves, microwaves, infrared, visible. However, the ionizing rays are the ones that can cause real damage to our cells, our DNA and atoms. Ultraviolet, X-ray and gamma ray, and we've also already said that these are the sorts of electromagnetic rays that can cause problems with our skin, in particular cancer. So, what are the things that you should get out of this lesson and the questions you're doing from the textbook? Well, you should understand that electromagnetic spectrum consists of transverse waves only. Sound waves are not part of the electromagnetic spectrum, and they are longitudinal waves. You should be able to describe the different types of wave that make up the electromagnetic spectrum. So that's from radio waves with the long wavelength up to gamma rays with the short wavelength. And finally, you should be able to explain the uses and the dangers associated with the electromagnetic spectrum and the different sorts of rays or waves that are on that spectrum. All right, well, good luck with that. And if you have any questions, make sure that you either email me or ask me in class.